Okay, welcome everyone to the third journal club. I'll start sharing my screen. Oh, can you all see that? Okay. Yeah, cool. Okay, so this paper was one of the first papers that looked at fairness in machine vision, and it was also one of the first papers that looked at intersectional disparities in machine learning. So often the papers were mostly centered around one protected category at a time, and this one looked at gender and race. So firstly, I want to draw attention to the results. So they found that 34.7% was the error on darker skinned females compared to 0.8% error on white and lighter skinned males, which obviously shows that there's a huge issue with not just a racial disparity, but a gender disparity that intersects for both those types of identities. So as machine learning gets and AI gets used more in like what people get themselves involved in, that's what people call socio-technical systems. So for example, hiring, loaning, how long an individual spends in prison. So if you guys have heard of the Compass case, which was to predict if people would reoffend, and it turned out to be extremely inaccurate, where they would predict that, you have heard of it, Cayman, is that you nodding? Okay, good. Where they predicted that Black men were more likely to reoffend, and then what happened was they actually weren't reoffending at the rate that they were expecting, and then also white males were reoffending more than they were expecting from the algorithm, which caused them to, I think, retract the algorithm at that point. But in terms of face recognition tools, they're starting to be used a lot, for example, in our phones. I believe police in America were using them, and I also actually think the Met Police were using them at some point. I'm not sure if they withdrew their use of that, but I hope they did, but I'm not sure. So another example of machine learning exhibiting these kind of biases is in the word2vec. Cayman, you've probably heard of that, haven't you? Yeah. And in that one, the analogy generator, it said a man is to a computer programmer as a woman is to a homemaker. So these systems aren't able to ignore the stereotypes that exist that we've in our society have created over years. Another example is in loaning and credit applications. There was a study done in America, which I can't remember the name of right now, but they were giving out loans at a much lower rate to Black families and Black homeowners. And that was purely based on an algorithm they were using that said that they would be less likely to pay it back. And that's obviously based on a historical context, which they didn't account for. And they just took the algorithm result as face value. So I've drawn these arrows to just draw attention to some important points. So at least 117 million Americans are included in law enforcement face recognition networks, and a year-long research investigation across 100 police departments revealed that African-American individuals are more likely to be stopped by law enforcement due to the facial recognition, especially in areas which have more police surveillance, tend to be Black areas in America and in the UK as well. So when that is being used, it increases the police state. And if you guys have heard of like the new Jim Crow, so the Jim Crow was the segregation laws in the 60s. The new Jim Crow was the police system. And then there's this book called The New Jim Code, and it's how programming is just enforcing that even more. And another case where machine vision is enforcing this is in skin cancer predictions. It doesn't work as well for darker skinned people, which means that they don't get the diagnosis they need, and obviously that can cause extreme health risks. So in this paper, they examine, actually they don't examine Google, and I'll get to that in a bit, but they examine IBM, Microsoft, and Face++ machine vision algorithms to test on a data set that they create. So IBM is American, Microsoft is American, Face++ is a Chinese machine vision company, I believe. So I'll get to that. Yeah, so this is they decided to create their own data set. So as you can see, they took countries from Rwanda, Senegal, and South Africa, Finland, Iceland, and Sweden, because on other facial recognition databases, so not the algorithm, just the database, they found that they didn't use the same lighting, the same positioning, and stuff like that. So it wasn't very useful in machine vision, especially cameras are actually optimized for lighter skin tones. So if the light is already different, then it's not going to be a very good data set. And I think the table is, where's the table? One second, guys. Okay, I can't find it, but I'll probably get to it. But the other databases, they disproportionately had lighter faces to about 78% or 80% of the whole database were white faces. So obviously, if it's trained on that, it's not going to be very accurate for darker faces. So that is why they also created their own database. And they've used all these pictures here are of parliamentary members, because those are the photos that tended to be all of the same position, all of the same lighting and stuff like that. The way they classified darker skin in their algorithm was by the Fitzpatrick scale. Does anyone know what that is? No? So it's a scale of 1 to 6. So it's 1, 1, 1, 1, 1, 1, 1, V, V, and VI. And the first 3 are like the lighter skin types, and the last 3 are the darker skin types. It's used in dermatology so that they can be treated for skin cancer and stuff like that. And it's not just to do with how light or dark you are, but how you react in the sun. So that's how they use it, rather than like ascribed or prescribed labels, because that can vary quite a lot, whereas a Fitzpatrick skin scale is more concrete. So this is what they called their database, was a parliamentary benchmark. That's why it's called Parliament's benchmark, because it's members of parliament. So yeah, their skin type labels, as I said, was a Fitzpatrick 6-point labeling system. And so they chose 1 to 3 as light and 4 to 6 as dark. And that's how they classified with, they used 4 classifications. It was dark skin male, dark skin female, light skin male, and light skin female. They also make a note here, which I think is quite important, is that a lot of the gender labels that they got from the photos themselves were the reductionist view of gender. So it was binary, and it didn't take into account non-binary identities and stuff like that, which is important, but they did make a note of that, so that's good. And so this is this table here is the breakdown of the images that they have. So they try to keep it as balanced as they could to male, women, dark, light. And this is the table I was looking for earlier, which shows the difference. So the Adient's data set only has 13.8% of darker skin tones in their data set, and the IGBA only 20.4%. Even with the PPBA, it's 46.4, but it's nearly 50-50, so it's a lot better. So these are their key findings. The 81.8.1 to 20.6 was a difference in error rate on male to female faces. Light to darker faces was 11.8 to 19.2. And they all perform worse. So the highest error rate was 34.7. And then as I said earlier, the lightest error rate on a light-skinned male is 0.01%. The Face++ performed the best on the darker male faces, which could be to do with the fact that it's in China and not America, because Chinese people will also have darker skin tones, whereas European skin tones don't vary as much. There is some variation if you go to like Southern Europe, but the variation is less if you just take Northern Europe. And so here they use PPV error rate, TPR, FPR. So TPR is true positive rate, FPR is false positive rate. And this is the breakdown of the different classifiers on their new data set, so on the parliamentary data set. And it shows that all 3 of them are more accurate on lighter men and much less accurate on darker women. So this in all shows that if you don't audit and aren't careful of how you not just choose a data set, but how you train an algorithm, that it's going to come out inaccurate. And they also note that a quite important point is not just that the algorithms and the data is wrong, but actual cameras are not optimized for darker people. They're optimized for lighter people. So that's an issue for like actual camera companies, which I guess machine learning can't solve unless there was a new algorithm created to optimize specifically Black and darker skinned faces. They also noted that, so this is the plot here. This is over IBM. They also wanted to check that it wasn't to do with, because the camera has less quality on darker skin faces, they wanted to check that that wasn't what's causing the inaccuracy. So they actually looked at just the South African results here. And they still, because the South African pictures had less quality across the board, and they also had a much wider range of light to darker skin, and they still found that that error was still there, which means it wasn't due to the low quality of images. So yeah, that's pretty much it. If anyone has any questions, if anyone wants to talk about that, I know I might stop screen sharing because I know Cameron can't talk.
Yeah, I mean, it's just quite interesting, the public responses to this sort of stuff, because I remember it was very much in the midst of like the early pandemic that IBM came out to say that it's halting all current and future offering and research in facial recognition. Pretty substantial for any sort of big company to take it that hard on themselves, like take such a loss to forward the fact, or to try and expose the fact that there's such rich bias.
Yeah.
So it's very interesting. I agree.
I can't remember if, I'm just going to Google it quickly, if Met Police ever stopped using their facial recognition.
Yeah, I can't remember. I think most of the American police system still uses whatever the Amazon one is. I can't remember what it was called.
Yeah, so I've just gone onto the Met Police, and they still use the live facial recognition. I don't know why they would still use it, given they know how it works and what it's doing, but yeah. Does anyone else have any quick questions before I move on to the next one?
Kevin had a bunch in the chat.
Oh, okay.
I'm surprised by the worst performance on female faces compared to male faces. Do you know why that is?
I'm just checking to see if it was to do with the data. It doesn't break down the difference in the data set, but I assume it's because that there must be, if it's not in the data set, there must be something in the code that is optimizing to male faces, although I can't imagine what that would be. Let me have a look one sec. Yeah, it's a good question. I'm not sure. It'd be interesting to see the architecture, but they don't actually share the architecture, which is something that they mention in here, that it would be much better for communication, understanding what's going wrong if they would actually share the model that they're training on. But yeah. Do you say NLP is having a boom and focus on gender bias, but not much on racial bias? I remember seeing one paper or a couple papers about it detecting like African American slang as aggressive. Yeah, and I think maybe it was Grammarly, that the way they were texting, Grammarly had like a sentiment analysis tool that it was declaring it up as, oh, you're being aggressive in this email or in this text. Yeah. I'm not sure if it was Grammarly, don't quote me
That's
on
so
that.
awful.
Yeah.
Oh God.
Okay, I'll go to the next paper. I'll start sharing. Can you guys see it? Ah, come on now. Now can you see it? Okay, so this paper, this is one of my favorite papers in this field, I think. It's one of the first papers that tries to incorporate theories from sociology into it. So it's the first paper to try and not use racial categories, because that in itself is an issue studied in sociology, that by actually classifying people, you're just reifying that is a normal way that we should be as a society, because race isn't just an arbitrary way that we've decided to classify ourselves. It was created as a hierarchy, and it still exists as a hierarchy of social needs, of housing, of how people are treated. So they start with, these are three of the main definitions that I use in fairness. So fairness to unawareness is just if you don't use the label. You just put in data and you don't say if they're Black, white, Asian, whatever. This one is that demographic parity is that the probability of, if it's a binary classification, the probability of being either is the same. Yeah. And equality of opportunity is that it's of equal likelihood to be predicted false or negative. So I think that's false positive rate and negative positive positive, I'm saying it wrong. False positive rate, true positive rate, there we go. So they raise later that the issue with this one is you can ignore the actual category, but it will still filter down into the data. For example, in housing, in schooling, you might not have said the race, but it can be inferred by the system, and therefore it will just reproduce the bias because you just decided to ignore it, because there's no such thing as being colorblind, if that makes sense. And then these two, the problem is what they try and address of actually using the racial categories in itself is a problem. You reify that these are suitable ways that we should construct our societies, and they're not just, and that they're just arbitrary ways in which we decide, oh yeah, you have blue eyes, you have brown eyes, and that's just how we organize, when actually it's just a symbol of how people are discriminated against. So they go through some examples. This is the Compass case again, the recidivism prediction. I won't go over that because I already mentioned it. So Facebook, this is an example of Facebook using, not explicitly using race, so the colorblind theory, but then it being able to be used by people who use this. So what they did was they created they let a platform, which a company called Ethnic Affinity, which was so that they, without knowing their race, they could figure out what people's interests were, and they were, because of those interests and what they associated with on Facebook, and those are like cultural things, they were able to realize the race of people. And then this ended up being that they wouldn't advertise housing to Black people on Facebook. So although they didn't intend it to be racist, someone used it to be racist. That's a problem with the first definition that I mentioned here, the fairness through unawareness. So they also talk, this section is really interesting, it's less machine learning based, it's more of the sociology side. It's about the origin of political racial categories. And I like, this is why I've highlighted this definition. I thought that was a good definition of what stigma is. So it's the co-occurrence of labeling, stereotyping, separation, segregation, and status debasement and discrimination. So the act of labeling in itself is stigma and segregation. And that's what these two authors are trying to get rid of. So this is mainly, I think it's all actually about American history of race, but it obviously links very strongly to Europe as well. And it also highlights how racial categories have changed over time. So before here, I think they talk about before the one drop rule was introduced. Do you guys know what the one drop rule is in America? Okay, so in what year was it? So it's here. In 1910, oh no, in 1930, sorry. In 1930, they introduced the one drop rule, and that's if you have even the slightest ancestry to Africa in America, you are considered Black. And that would mean that you could not tick white on the census. And that would mean that you are subject to segregation in schools, etc., etc. And it was treated as like a tainting of whiteness, which is why it's called the one drop rule. But this changed after World War II, and that's what they went with, because they didn't want to associate with Nazis because it became associated with Nazis. So that's also led to the civil rights movement, which we know about, Martin Luther King, which ended segregation, but then came in the new Jim Crow, which is the prison system. And there's a whole book on that. It's a very good book, so I'd recommend it. This is also an important definition that they use. So a racial project is simultaneously an interpretation, representation, or explanation of racial identities and meaning, and an effort to organize and distribute resources, economic, political, cultural, along particular racial lines. So for example, the Facebook thing I mentioned, the ethnic affinity, wasn't meant to be a racial project, but it ended up being a racial project because people used what they gave out. And like they said here, it can be racist, anti-racist, or neither, depending on how they align. So in this case, the Facebook was neither, and then it became racist. So these are the ways in which we see or define ourselves by race. And I think this is quite a good diagram to illustrate it and where it comes from. So a lot of, if you don't really think about it, people will just think, oh, it's purely just, you come from here, so that's what you are. But it's, as I've said before, it's what it is at its core is just a way that people have created a hierarchy to justify gaining power and so on. And I put this note here because they highlight that, they actually talk about the paper I just talked about first, where it doesn't take into account colorism and how the criminal justice system will favor lighter skinned Black people over darker skinned Black people. So it really is like the lightest at the top, darkest at the bottom, because the closest you are to white, you get more privilege. Are you still looking at that, Rachel? Okay, let's go.
Yeah, I was just wondering what the categories refers to under the branch of nationality.
Oh, here.
Yeah.
So I think that means ethnic categories. So
Okay.
so if your nationality is, say, British, then your ethnic category is English, I guess. You wouldn't be Scottish or Welsh. I think it would be English. And then your race becomes white. Yeah.
That makes sense. Yeah, thank you.
And there's also what I was talking about with how race changes over time and space. There's a really good book called How the Irish Became White, because like if you know about UK history, in like the 70s, pubs used to say no dogs, no Blacks, no Irish. And the Irish weren't, especially, it was in America as well, it wasn't just here. And I believe in America, it was also Italians. They didn't, weren't considered white. And I think it was to do with them being Catholic and the British being Protestant, because I know there was that fight with the IRA and stuff. But yeah, it's a good book. So this is the way that they analyze the input data, the output data, and the software. So blind to race, which was the Facebook one, but then the output data ascribed race and was up to user interpretation. So it became a racial project, even though it didn't start as a racial project. So like, sorry, let me zoom in. Is that better, guys? Oh, it was a bit zoomed out before. So this is what Facebook's one was. It was this one, and then it became this one. An example of one that is designed to be a racial project would be let me think. I guess the only ones that are designed to be a racial project now are the ones that are trying to counter the bias that's coming into existence. I guess before it was accidentally coming into existence in the algorithms. Okay, so this image is the cycle of racial formation. And if we aren't careful in machine learning, we take part in mainly these two. And it's just a cycle. So that's why fairness needs to go beyond just, oh, we need to fix what's going on. You know, it needs to be actively engaging with like social sciences and stuff. So now this is where they present their alternative. This gets a little bit more technical, but I think it's okay. So instead of using ascribed racial categories for the input to the algorithm, they will create race-like labels through spatial segregation and social segregation, which then can be fed into a group definition of fairness that, oh, like they're all being treated equally and etc. But so this is the original definition of dissimilarity, but obviously these are white, black, already classified labels. So here they outline how to change it. I'll zoom into that so you can have a better read. So they basically adapt the spatial and social segregation so that it can infer when people are being segregated in the data rather than them saying, oh, they're black, they're white. And they do this by literally spatial analysis. So X is a vector of, oh, sorry. I is the range over the indices of land tracts. So it will separate, like, let's say, if you want to take Georgia, for example, like the state, you'll be able to see which areas some people live in. And then you'd also, using this vector, you'd be able to see their economic class, what schools they're going to, stuff like that. So you can aggregate, oh, they're in this space and they're also, like, for example, these people in this space are poorer and these people in this space are richer. That would be spatial segregation. And then similarly, social segregation. This is also the original definition that is supervised, not unsupervised. And it's adapted in a very, very similar way to what I just mentioned. But yeah, I think this is a good paper to, because usually fairness is done in supervised learning, not unsupervised learning. So, and that will always rely on racial categories and gender categories, etc. And the good aspect of this is not only can it detect discrimination that's occurring, but it could detect discrimination that we're actually not aware of. So if, for example, there's a group that in general is not aware in the political eye that, oh, they're being discriminated against, this could detect that. So that's a strength of the paper. I don't think they mention it here, but one weakness that I find of the paper is that race-like labels will be taken as race labels. So they're not completely avoiding the issue of reifying race categories, but it's a step in the right direction, I think. Okay, that's it. If anyone has any questions.
Yeah, comments in the chat again, I think.
Yeah.
With the approach in 5, it is likely to segregate categories we might have not considered before.
Cayman, you said, okay. Figure 1, the model of race is quite interesting. Have you seen it being shown elsewhere? I don't think I've seen similar ones. I haven't seen this specific one. I'm pretty sure they've come up with this one, but this is something that's studied in sociology. So I haven't read that many sociology papers. So this is the first time I've seen it come up in machine learning papers. But yeah, with the approach in 5. Oh yeah. I see. That's a good question. That's a very good question. I'm not sure. I would say that if it came up that a certain area was drinking a lot of alcohol, or say doing a lot, I know yours is specific to wine, but if it was certain areas drinking a lot of alcohol, a lot of like say doing a lot of drugs, that could be linked to also poverty. So that it could still be relevant. But I guess with human annotation and stuff like that, you could figure out what's significant, what needs to be more looked into in terms of policy and stuff. Anything else? No problem. Okay, the next paper, I'm not sure if we have enough time to go over it in detail, but I'll go over it quickly if it loads. Okay. Can you guys see that? Okay, so this paper was about comparing how people who aren't familiar with machine learning view different fairness approaches, and they use a descriptive, and this is a descriptive ethical approach. Normally fairness is seen as like a normative approach, which I probably agree with, that it's a more, you need to take a more normative approach than a descriptive approach, but I read this to like see what other ways you could do it. In short, they found out that people, so they did like these kind of tests, like they gave an example of, oh, there's these two algorithms and they discriminate, one discriminates more than the other, or this one does this, and basically asking the people, oh, which one like seemed better to you and why. So they would give a reason as well as just saying why. They found that across all, so they tested it on the criminal risk prediction. This is coming a lot up in all of the papers. And again, the skin cancer risk prediction. What they found was that if the risk is high, so for example, with skin cancer prediction, they will trade off equality with accuracy. So they'd rather it be higher accuracy than higher equality. So I'll show you the table down here. Is that page not loading? Okay, that's weird. Anyway, okay, I'll just talk about what it said then. When they were comparing skin cancer risk and flu risk, they found that even if it was unequal, so for example, if the accuracy for women's diagnosis was lower than men's diagnosis, but the accuracy overall was higher, they'd go with that, because even though it meant that women would be at higher risk, I guess, overall it would save more lives. But for example, with the flu risk, because it wasn't high stakes, they went with higher equality over higher accuracy. And this is a reason why I'm not so sure I agree with the way with using a descriptive approach versus a normative approach, because yeah, okay, so it might be more accurate overall. So does that mean we should just let women like get less accurate predictions? So I didn't think that was a very good way to go about deciding what's fair and what's not. And that's why normative approaches I genuinely think are better. But yeah, they also found that across the criminal prediction and the skin cancer prediction, that the demographic parity definition of fairness was the one that people tended to agree with. I believe that was because it's the simplest one. And they also, what I didn't like about what they did was they didn't actually explain the algorithm. So everything they did, oh no, not up here. Yeah, up here. Oh, it's disappearing. Okay, this is really annoying. But okay, so you see these, I know it's really tiny, so it's really annoying, but the graphs here, they use an algorithm to match, sorry guys, they used an algorithm to match what people thought was fair to a fairness definition. I'm really sorry, I don't know how to make it work. Oh, there we go. Okay. They use a algorithm called the EC squared algorithm to match what people thought was fair to a fairness definition. And I also didn't think this was a very good way. I think you should actually explain what the fairness definitions are so people can make an accurate choice of what they want to pick. They also, they say here that their sample group wasn't very representative, so it was quite young compared to the census, and it was also quite on the left of the political spectrum. And I think if they used more people on like a conservative side, you would probably get some different results. And I don't know. In general, I don't think it's a very good approach, because if, let's say 100 years ago you did this, oh, like how should the most fair way be? There'd be a lot of people that said, well, I don't care what happens to Black people, I don't care what happens to me. So like, I just don't think you can always approach ethics in that way. So yeah, that was quick because we're running a little bit short on time, but yeah. So does anyone, let me stop sharing. Anyone have any last thoughts on that paper? I didn't particularly like it. I don't know about you guys. I prefer the normative approach of thinking about what we should or shouldn't actually be doing in like a more metaphysical sense, rather than what do people think is right. And I also didn't like that they didn't explain the algorithms to the people taking the surveys, because I can also imagine if the survey is really long, people might not be even doing it seriously. They might just be picking the simplest solutions, the one that makes the quickest sense, rather than actually looking at the complexity of the situation. But yeah, anything else? Any last questions or anything? Okay.
I'm all good.